So, good afternoon. My name is Roberto Conti. I'm a senior research engineer at IUVO SRL. And today I will speak about the case of the active pelvis orthosis in the framework of lower limb rehabilitation. These are the contents of the presentation. I start with a brief introduction about IUVO. Then I go ahead in presenting the active pelvis orthosis. Here you see the acronym APO, okay? That is a hip exoskeleton to be used in rehabilitation. And finally, I will show you some results that we got from the clinical studies carried out in the last 10 years. So, where we started? In 2015, Professor Nicola Vitiello from the Biorobotic Institute of Scuola Superiore Sant'Anna founded with his colleagues IUVO, that is a company aimed at developing wearable technologies. As you can see here, IUVO has an agreement with SSA to exploit the technologies developed in the wearable technology lab. Okay, and in 2017 we were acquired by a joint venture between Comau and Ossur to foster the adoption of wearable robotic technologies in the industrial and medical fields. Here you have our main objective, that is, as I said before, our aim is to develop wearable technologies. And on the right side of the slide, you have some examples of the device that we developed in the last years. In particular, you can see the MATE exoskeleton. That is, we have two versions. The first one is for the upper limb, for supporting overhead tasks. And we have the MATE XB that instead has been developed for supporting lifting tasks. Both devices are completely passive, without electronic, without batteries, only spring-loaded mechanism, and they are commercially available through Comau. Okay, these are exoskeletons developed as occupational exoskeletons. So, exoskeleton aimed at supporting operators in working tasks. Instead, on the right side of the slide, you have the APO technology that has been developed for supporting walking tasks. And in this framework, we are collaborating with Ossur, that is an Icelandic company working in rehabilitation, to develop a hip exoskeleton able to improve the walking capabilities of the subjects. And then later on, I will tell you more about the clinical studies that we carried out. Okay, so in this slide, you can see the three sectors in which we are active as IUVO. In particular, starting from the top, we are working in the industrial field in collaboration with Comau. And for Comau, we are developing, we developed in the last years different technologies, the MATE that I showed you before, okay? At the bottom of the slide, you can see the other sector in which we are active, the medical field, and in this case, IUVO is collaborating with Ossur to develop this kind of technology. In the middle, we are active in the consumer market as IUVO, okay, to develop wearable technologies, wearable exoskeleton in the fitness domain, okay? It's important to say that some technologies has been developed in the framework of European projects. On the left side of the slide, you have a list of the European projects in which we are partner, okay? Some are still active, some are concluded, but some technologies has been developed in the framework of these research projects. And this is very important, for investigating new technologies and new paradigms. Okay, so let's talk more about the APO. Okay, as I said, APO is the acronym of the Active Pelvis Orthosis. The device is a portable, wearable, powered hip exoskeleton, okay, able to provide flexion extension torque at the level of the hip, okay. We started in 2012 in the framework of the CyberLex project, that was a European project, and in this project we developed two versions of the device, the Alpha APO and the Beta APO. Okay. In 2016 we developed a Gamma APO thanks to national projects, and in the framework of the CyberX++ project we were able to develop two other versions of the device, always with the idea of increasing the maturity of the technology as well as reducing the weight. Okay. Finally, we got in 2022 developing the CT APO, that is the version of device that we are still that we are using in two clinical studies that are running right now, one in US and one in Italy, okay? And I will tell you more later. And finally, you see the last version of the device that we developed in 2024 that was called APO Gym, because this version was the first one thought to be used in the fitness domain, okay? And again, here you can see that the road was very long, and thanks to the European projects, we were able to develop this complex technology. A brief description of the device, of the main components of the system. We have a physical human-robot interface that is the part in close contact with the user, okay, usually made of soft and rigid materials. Then we have a backpack embedding the electronics and the control hardware. The actuation unit, that is the core of the device, where we have the motor and the harmonic drive. The transmission unit to transmit the torque to the user. A passive degree of freedom that is useful to have a non-collocated abduction movement. Okay, and finally the carbon fiber link. Main feature of the device are the following. So in the years, as you saw before, we worked a lot to reduce the total encumbrance and the weight of the device to reach a real slim fit and lightweight design. Okay. We work a lot also on the donning, the self-donning of the device. This was really important for the APO gym, so the device thought for the fitness domain. And finally, we developed a device that with just a few adjustments can be easily adaptable to different anthropometries. From the control point of view, very quickly, we can say that the device is able to provide torque bilaterally. It's important to say that we can provide different torque on the left and right side. Okay, so we can provide the symmetrical or asymmetrical assistance that is very useful for rehabilitative purposes. We can also support the physical therapist to design an assistive profile that can be useful for mitigating the specific gait impairments of the subject. And in this framework, the APO is a platform that can provide a fully customizable assistance that is very unique in this framework. here I got a video, but it's not working, sorry. But here, basically, one important result that we got in the framework of the CyberLex++ project was that we were able to demonstrate that with the APO, the subject can walk faster compared to the same condition without APO. So it was a very important work and important clinical study to demonstrate this feature of the device. But let's have a look on the different clinical studies that we got in the last 6 years, more or less. We started in 2018 with 2 different clinical studies. It's important to say that this kind of technology cannot be validated if we don't use the device in real clinical settings, because an exoskeleton, it's a device, but it's important to understand the real impact of the final end user of this technology. And in this case, we were able to demonstrate that both, that either on hypomobile elderly subject and chronic stroke subject, I don't know what is this sound. Okay, we were able to improve the speed and the endurance of the subjects. Then we go ahead in our study, we develop the technology, we improve the technology, control algorithms, we improve the maturity of the different components, and we did other 2 studies, one in 2019 on transfemoral amputees, where we use the device to support and to improve the gait speed of the subject, and in 2020 on chronic stroke subject. And in this case, we were able to really see the impact of the device as an assisted device, having, let's say, a faster speed of the device of the subject with the device with respect to without the device. Finally, 2022, we did a study on Parkinson's disease subjects. And finally, as I said, we are testing the device on chronic stroke subjects in a multicentric clinical study, one in Italy here and one in US, to see if the device applied for a long time, meaning 1 month of treatment, okay, can be really useful to improve the performance of the subject, and therefore to introduce this device in the real rehabilitation settings. And this study, is still ongoing, and we have the idea to conclude the study by the end of 2024. So basically at the end of this year. So just to recap, the clinical studies that we did in the last 8 years in a nutshell, okay, we treated different populations with our device, mainly focus on, mainly investigating subject, transfemoral amputees and post-stroke subjects, patients with Parkinson's disease, and hypomobile elderly. So in this way, we were able to understand if this technology can be useful for this kind of populations. We treated more than 80 subjects, and we, have a safe device, because at the end we never happened serious adverse event, okay? And we tested the device in 3 different countries. So to conclude, this was a brief presentation about the story of the APO, and we can say that this is a great example of technology transfer from European project to a company, okay, that has been created with the idea of transferring the technologies developed in the academic world in real-world application. It's important to say that thanks to these European projects, we had not only the possibility to develop the technology, but also to test the technology and validate the technology in real clinical settings. Therefore, we can say that the APO technology is almost mature to get on the market. Okay, if you have any question, I'm here. Thank you.
Thank you so much for your presentation. Do we have any questions from the audience?
Maybe a question from
the AI. I have a question myself, actually, two questions. One is more technical and the other is more general. So the technical point of view, I probably didn't get it from your presentation. What is the activation mechanism for starting the motion? Yeah. And then the second question is, if you have an idea of the global market value at the moment for clinical and non-clinical.
Yeah, okay. Okay, thank you, Lorenzo. So regarding the first question, in our exoskeleton, our exoskeleton has been developed for people, for subjects that had a residual mobility, meaning that they are able to walk, autonomously, and the device is able to recognize the gait pattern of the subject and to start the activation of the assistance. Okay, so this was, let's say, the main. Yeah, exactly. And regarding the second question, instead, since I work in a company in the wearable technology, working on wearable technology, we can say that the market is really big, especially in the medical field. But in the last years, even the occupational exoskeleton market grew a lot, and now we have a lot of competitors in this kind of field. So I think, there are a lot of research about this kind of, about the size of the market, but we can say that it's really big. Yeah.
So it's a promising market.
Yeah, okay. Hopefully.